Hello guys, welcome to another video with Cass on the Maizuma channel. You know what? I just realized that I have been slowly building a kind of data transmission series on my channel. It's totally not intended, but yeah, it is in here. I have been talking about data transmission for a long time now, and this is just one more great example. So we have talked about serial transmission in the past, but I wanted to show you guys this device because it's really cool. It has all the functions in only one device. So yeah, it actually has three functions, and yeah, let me show you how it works first, and then we can discuss the details. The idea here is that you want to send a code into another place. This code is supposed to do something on the other side, but it's up to you what the code is supposed to do. But the thing is, the system will allow you to do that in this specific way. So let's try to build a pattern in here. So we have an alternating pattern in here. So on, off, on, off, on, off, and we can press this button to send information to the next node. And as you can see, we have on, off, on, off, on, off. So yeah, this is the first functionality. It receives data, so we can change the pattern. So this is a really good pattern because it tells you whether the device on the other side is receiving the first bit and the last bit. So send the data again, and so yeah, every time you have new data, you can send information through a single wire to the next node, and yeah, this is binary information. The next functionality I want to show you guys is forwarding. Once your node has any sort of information, you can activate this block, or I'll just use a button in here, and then it will forward information. So now information that was in here is still in there, and yeah, it has a copy in here, so it can forward any kind of information it has. And you don't actually need data in here but I mean, you don't need to turn on any of those levers to transmit. You can transmit a completely blank pattern. As you can see, it's yeah, it's completely blank, and you can forward this. Yeah, and now we have a cleared device, which allows me to show you the last thing that it can do, which is to also encode information. So I can let's try something, because the next node that I have in here is connected to a decoder, this big science circuit in here. And what it does is, since this is a code, which is a combination of those levers in here, we can make this code be decoded into multiple lines that can activate multiple things. Since we have 6 levers in here, there are a total of 64 combinations that we can do, which means that we can activate 64 different things on the other side. So this is really cool. So for instance, if I send the 0 that you see in here, you will notice that the first lamp turns on. If I change it into a 1 by flicking this lever in here, I can press the button. I will just use Optifine, and then the second lamp turns on. So yeah, in binary, this would be a 2, this would be a 3, this would be a 4, and this would be a 5. Let's try the 5 just to make things a little bit more interesting in here. And yeah, so if we count it, this is code for 5, 4, 3, 2, 1, and 0. So yeah, I'm just decoding for 16 different codes in here, but you can keep extending this pattern in here with this decoder, and imagine this only 4 times bigger, because this thing can decode 64 lines for you guys. So yeah, 64 things that you can activate on the other side. You can activate 64 different functions, or you can use part of the data, part of the bits for data, and like the first 2 bits are control, so you can execute a command. So command 00, command 01, command 10, command 11. So 4 different commands, and the data is the 4 bits that follow it. And you can keep forwarding bits like this and put them together in a final device. Yeah, so that's all it does. It can execute those 3 functions: transmit, receive, and forward. And this is the core of my new minecart station system. If you guys have been following my the development with this kind of design, and yeah, and now I'm gonna do a tutorial for you guys. Okay, let's start with the transmitter because it's really easy to do. So you just need a block with a button and a lamp, and then here 6 lamps and 6 levers down there, because you're going to encode things using those levers. And on this side, you're going to place 6 sticky pistons with solid blocks on top. and then this guy, which is the one responsible for sending information, is going to be like this. All right, so from here, it's going to power it like so, and then you can place 7 observer blocks. So 1, 2, 3, 4, 5, 6, 7, and then just place one more piece of redstone dust in there, and then 1, 2, 3, 4, 5, 6 repeaters. They must be all on one tick. And yeah, the way you control it, you can now place, I'm getting ahead of myself. Okay, you can just place redstone dust in here, and then your output is going to be this repeater or this block, doesn't matter, like so. All right, and the way it works is you can make your code in here, and then those blocks will be where the observers are. And then when you press the button, yeah, you can see this blinking. So yeah, this will send a pulse. The pulse will travel in here, and then the binary code will be sent. And the reason why we have 7 observers in here is that the first pulse is always active because it wakes up the device. Keep in mind that the device never knows when information is arriving, so we kind of need to send it a little pulse so that it wakes up, and then we can send all the data. This is especially useful when you want to send a blank pattern like this, because otherwise you would basically be sending nothing through the bus. All right, now comes the fun part where we'll build the actual transceiver. So we start by adding 6 repeaters in here. So 1, 2, 3, 4, 5, 6. Wow, that was exact. I wasn't really counting. Okay, and you connect those with redstone dust. Don't use solid blocks in here. If you want to know the reasons, watch my other video where I show you how to do expandable serial transmitters. They're also pistonless, totally silent, totally solid state, so some of you guys might like it. And then I explain the reasons where, for instance, why am I not doing this with all the repeaters close together, because this is a lot more compact, but it doesn't work because the game has bugs. All right. And now we need to lock those guys. And you need to lock those using comparators because of the update order. This is very important. If you use comparators, this is always going to be consistent. And now we have a regular piston in here. It's important that this guy is a regular piston. And now we need 11 blocks in here. So only 6 actual redstone blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, and then we need to alternate those with something. It doesn't need to be glass, it can be solid blocks, but I just like to use glass. It makes it easier for you guys to see it as well. Okay, and finally here is where we're going to have the opposite piston. So you can build this smaller. So this one is for 6 bits, but you can build it for 5, 4, or even 3 bits if you want. And the rule that you have to use, of course, you just place less repeaters in here. So for 4 bits, just use 4 repeaters in here. This should be obvious. But the rule that you have to follow here is the number of blocks that you place in here, the number of observers. So because this is 6, we need one less one number less for observers. I can phrase it, but yeah, 1, 2, 3, 4, 5. So this was wrong. So one more. So yeah, this is the thing that you need to do in here to activate the other side. So 1, 2, 3, 4, 5. 5. It's 5 because it has 6 bits. So this is all you need to do in order to make this work. And now we create the bud in here. So by placing this, it will already work. So this is already budded. But I noticed that sometimes this guy can fire multiple times, because what happens is this guy is budded. So when anything happens in here, this piece of redstone dust will update the piston in here, right? And also it updates like 2 blocks from the redstone dust. But if it ever changes in the game, you can also place redstone dust in here. It's not a problem. This is actually how the design usage should be. But just make sure that your signal strength reaches both blocks. All right. Another thing you can do is to have your input like this. And I'm not prepared to do this. I'm just remembering this now. And just use a rail in here, so the rail will also update this thing in there, right? So no problems in there. I like to give you guys all the possible cases that I can so that you don't have trouble when building this thing. Okay, and next up we need to add a piston in here and then a repeater on 3 ticks in this case. So if you build it with less bits, so it's less than 6 bits, sometimes you need to change this into 2 ticks for instance, but never 1 tick. So for this one, it's 3 ticks. You have to experiment with it. And then hook this up with the redstone dust in there. So let me show you everything that we have so far. And yeah, let's move on to the next part. All right, so before we proceed, I need to fix a little mistake I made. So yeah, those blocks are placed in here, but this one is not optional. This block should stay in here. So I forgot to show you guys that this block needs to stay in there. And at this point, you can also already test your device. So this is the good pattern for testing. Let's try to be a little bit more creative in there. And as you can see, on, off, on. And yeah, this doesn't count. So the information is in there. This is working. So let's move on. Now we're going to create the part of the system that sends information and forwards information. So for that, we're going to have to place blocks in there. And these actually go down here like so. And we can actually break every other block in here. Some of those will be replaced, but it doesn't matter. Okay. And here, I like to use comparators. I think you can use repeaters here, no problem. Okay, and yeah, let me break this and this. So comparator. All right, so yeah, it is like this. Okay, so those are going to have pistons in front, just like this. And yeah, those pistons are going to be extended. So I'm just going to build. Let me build this first. So this is going to be 1, 2, 3, 4, 5, 6, and 7 because remember that this only stores 6 bits, but we also need this first bit in here to wake up the next device. This is why the transceiver needs 1 extra in the end. So just place your pistons like this, and then you can have solid blocks on all of their faces, and this one can have a redstone block. Yeah, because it's always going to be active. It doesn't matter what the data is. Okay, so this one is going to connect like this. So this one too. So you don't need to place this unless you're crazy for symmetry. You don't need to do anything like this. Because those 2 pistons will use the same channel in here. And okay, this one as well. This one, and this one actually needs 1 extra in there. Okay, this is not going to be a problem as well because this guy is going to be powered. So we can place this in there, and I believe this goes like this. So we place a torch in there and a block. So here we place repeaters all on 1 tick. So 1, 2, 3, 4, 5, 6 repeaters. So normally all of those pistons should be extended. And finally, here we place a repeater on 4 ticks, if I'm not mistaken. Let me check just to be sure, because lots of changes were made to this design. So yeah, this is only 4 ticks. So just to make your life easier in any case, if you need to do any modifications to this, the thing that makes this work is this this block in here needs to get a 2 tick negative pulse, if you know what I mean. So it goes shortly, and so yeah, this is exactly what it does, because it empowers the torch and then powers the other repeater, and then the pattern is sent through there. And finally, we can extend a redstone line from here. All right, we can place solid blocks in front of the repeaters, like so, and this is where your output is going to be. Yeah, so yeah, we can have redstone dust in there, and your output is going to be this repeater. So I used a solid block here on purpose because you might want to connect a repeater in here, because so then if you need to forward the signal, you can activate a pulse from here, for instance. So yeah, you do this and you can send the information. All right. Yeah, so let's test it again by sending another pattern in there. So it's 0, 1, 0, 1, 0, 1, so it's all nice and fine. And here, to test this, actually, what we can do is to loop this back, so we can connect this guy back into itself, which is kind of fun. And you need a little bit of delay, or you can build another unit. It's up to you. I will place a few repeaters in here, not just because of signal strength, but also because, let me destroy a little bit of this, it's getting confusing, but because we need delay. Because otherwise we're going to be writing and reading at the same time. It's not a good idea. So if you're doing this, if you're transmitting serial information, never do something like this. Um, First of all the repeaters need to be on one tick. You can never have repeaters on more than one tick. And you can never merge the repeaters like this, because data will merge because of bugs in the game. So don't do that either. Okay, let's try to place just a few more. All right, so we have the information in, and let's press the button to send the information to the next node, which is actually the same node as before. So yeah, you can see it in here. Let's try to change the pattern. Let's turn on these three in here. So 0, 0, 1, 1, 1. Send the information in there. Okay, 0, 0, 1, 1, 1. Maybe I should place the lamps to make it easier to visualize. It will cause more lag, but yeah, remember this one doesn't count. It's not it's after, it's whatever comes after the locked repeater that matters. Okay, so let's send the information. Yeah, 0, 0, 1, 1, 1. So yeah, I just created a loopback version of this. All right, so just to make things fun, I created a little thingy in here. So this is some sort of internet that we can make here using two devices. So those are copies of each other, and they can communicate with each other. So, and this gives you a taste of what actually happens in my new network system for the minecart transport. So yeah, the first thing we can do in here is just send a pattern everywhere. So let's send, yeah, this pattern 1 and 2, and in the end. So we can forward information to both. So 1 and 2 in the end, 1 and 2 in the end. So this is really cool. And the other thing we can do, I added this lever in here. It just causes an update to this piston, and what it does is it clears the device. So the other thing I can make is to make those stations communicate with each other. So this is the little internet. Let's try turning on those three and the last one, and then we can press the button to send the information. And there we go, the first three and the last one. It blocks the path, so it doesn't send information back to itself. And here in the middle, I have a two-way repeater. So this is the two-way repeater you need to use if you want to transmit serial information with that speed. The one with the comparators, the one people use with the comparators and repeaters, doesn't work for this. All right, and of course we can send information back. So let's just reset all the levers. All right, so it doesn't get interference with the new information that is coming. And let's create a new pattern in there. So let me first clear the device. Okay. Because you always have to clear, because the device doesn't know whether you want to forward information or create new information. This is why you need to clear. Okay, let's do this pattern. So yeah, simple to recognize. 0, 1, 0, and then 2 together. Oops, the button is this one. So use the two-way repeater, and then we can send information back in here. And as you can see, they are both the same. So yeah, two devices communicating with each other using a single wire and using binary codes. So as I mentioned before, now I have a playlist, guys, where you can check out all of the ways that I have developed so far of sending information to other places. So pulse length encoding and decoding, I think signal strength decoders, all kinds. Man, it's a lot. And this video is also going to be there. It's in the video description, guys, so please check it out. If you guys want a download map for this, let me know in the comments. I mentioned it before, but I'm not uploading all the maps automatically because I'm running out of space in Dropbox. So if you guys want the map, you need to tell me actually. So thank you very much for watching. Hope you liked this video. Hope you come back. See you next time. Goodbye.